Okay, so with just like yesterday where we had interpreting a fraction as division, it's the same thing, very similar to what we did second quarter, um, where when we have improper fractions or even regular fractions, we know that we can divide the denominator into the numerator. So when we're looking at word problems, which this is technically a word problem, a baker poured 4 kilograms of oats into 3 bags. What is the weight of each bag of oats? So what am I going to have to do to solve this problem? What do you need to do to solve this? Emily, what are you going to have to do? Okay, so what in this problem makes you think that you're going to have to multiply?
Oh no, you have to know.
Okay, so you changed it from multiply to divide. What part makes you think that now it's divide? Okay, so he's got 4 kilograms and he's pouring it into 3 bags. So what makes you think that that's division? Is it hard sometimes to put things into words? Sometimes it's hard for me to put things into words too. Imani, what do you think?
I think it's division too because we have 4 kilograms of trying to kill the right amount of
Okay. Uh-huh.
Because you put 4 kilograms of oats in each thing bag, so then you weigh one of them, and it's all the same weight, and you have to add them.
Okay.
Okay, I think it's division because this divide 4 into 3 because each bag has, it's saying like what is the weight of each bag of oats, and you're putting 4 into 3 bags. You can put 4 in 2.
Well,
That's how you say a problem, but
okay. So, and see, this is, I wasn't telling you if you were right or wrong either way. I was just kind of like, well, okay, either way. So, I was just, no matter what you were saying, I kind of go, well, okay, okay. So, I was trying not to give you any facial cues either because a lot of times you guys will look at my face and you'll go, oh wait, she's giving me your wrong face. So, I was trying not to do anything. So one thing that I know that a lot of you will try to do is you'll look for the key words. Were there really any key words?
no.
Well, it gives you each. Now, that one's kind of tricky because each can mean divide or multiply. It can mean either one. So you really have to pay attention to what the problem is telling you. So is it telling me multiply or add? Multiply or divide. So when it says that he poured 4 kilograms of oats into 3 bags, is it telling you that each bag got 4 kilograms?
No.
Or is it telling you that he started with 4 and he's saying, okay, this bag got some of that 4, this bag got some of that 4, this bag got some of that 4, where he was splitting up the original 4 kilograms. Or was he going, okay, this one got 4, this one got 4, this one got 4? So,
He only had 4. So there's only 1 kilogram in each bag.
so if you tried to multiply it, then you would be saying, this one got 4, this one got 4, this one got 4, to where you got a total of 12. Am I getting more oats? No. 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 Because it's not saying into each bag. It doesn't say each bag. So you have to pay attention. If you're using keywords, where is that keyword? It's in the question. What went into each bag? So I have 4 bags. Oh, sorry. The number 4 was in my. Yeah. Sorry. And see, trying to do the picture thing messes me up sometimes. So, yeah. See? I did it again. See, I had it right the first, or not. So it's 4 divided by 3. I had it like the first time and you messed me up. I had it the first time. So 1, 2, 3. 2, 3, 4. 1, 2, 3, 4. So what do you get when you do it in fourths?
4 fourths. 4 thirds. 4. 1 whole.
1 whole and
1 whole and 2 thirds. 1 third.
I was doing that in my head and I got
1 whole and 1 third. Now, using the picture is not my favorite, but it's an option. 3, 4. 3 goes into 4 1 time. 1 times 3. So you get 1 and 1 third. Now this is really what we're going to be doing today. The division, not focusing so much on the picture. No, because it's thirds. Okay. If he doubles the number of kilograms, how many kilograms were there?
4.
There were 4. So if there were 4 and he doubles it,
6. 8. So
8.
do you even multiply?
Equally into 3 bags. So that would be 8 divided by 3. So that would be 8 thirds. What would that fraction end up looking like?
2 and 3. 2 thirds.
So 3 can go into 8. 2 times. 2 times 3. 2 times 3.
6. Yes.
8 minus 6.
2.
So you get 2 and 2 thirds. So your whole expression, if we did the illustration, which not a thing, because you would get 24 thirds. If we broke down all the bags, you would get 24 thirds. And one thing that I can see, that one trend that I saw, is I could take my two numbers. That's where this comes out. I just kind of multiply them together to see how many I would get. 24. The second number tells me my denominator. So I would get 24 thirds divided by that number. Go ahead and divide those two. Again, it's just a long, drawn-out thing. You're really not going to have to do this a whole lot. So then I get 2 wholes and 2 thirds. Long, drawn-out, and wordy.
So I was right about you.
Okay. So what I did, let me pause here. So on letter A, it is already completed for you, but I'm going to explain to you what they've done. So on letter A, it says, they've got the division sentence for you. It says 5 divided by 4. Now, as I said a moment ago, what they've done is they've written it out in unit form. And that just means that they kind of broke it down for you by numbers and words. And so they've got 20 fourths. So if I drew it out with pictures or made fractions with it, so that I could say, I really truly, I could take 5 squares put 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I would have 20 pieces out of 20 fourths. They're all broken into fourths. I have 20 of them. That's where the 20 fourths came from. When I have 5 of them, 5 total pieces, and I'm dividing it by 4, now I have 20. So basically all I'm saying is you could take 5, multiply it by 4, that's where the 20 came from. So 4, I could say, okay, I'm going to be breaking them into fourths, rather than having to draw those squares. If you figure that one out a little bit. 5 and 4 will give me 20. The 4 will give me fourths. Do you see? I hope so, because I don't want to draw these out every single time. I'm dividing it by 4. If I have 20 divided by 4, I get 5. So, if I have 20 of these, and I'm only doing 4 of them, 1, 2, 3, 4, 1, 2, 3. So, I get 5 fourths. 5 fourths. So, it's 5 divided by 4 is 5 fourths. We're taking the division sentence here and writing it like a fraction, like we did yesterday. Division sentence, writing it like a fraction. That's all. First number is the numerator, second number is the denominator. I'm skipping the mixed number part. I'm going to actually divide it first to get my mixed number. I don't like how they put it in that order because it's in the wrong order for me. So when it says standard algorithm, that means work it. So denominator, 4 into 5. How many times does 4 go into 5? 1. 1 times 4 is 4. 5 minus 4 is 1. So then they went ahead and they wrote the whole thing right here. 1 and 1/4. which is where they got 1 1/4 right there. Now, the check. It's not hard, swear. It looks like a lot, but it's not. Swear, swear, swear. I keep saying swear a whole lot, like I swear, swear. It's not that bad. So all they did, you know how when I say check, multiply the top by the outside, you should get the number on the inside? The roof, multiply it by the yard, you should get the people in the house. Roof, multiply it by the people in the yard, you should get the people in the house. I haven't taught you how to multiply fractions yet. It's really easy. However, I haven't taught you how to do it yet. Multiplication is the same thing as addition. Repeated addition. Can you add fractions? Yes. So 4 times 1 1/4. How many times are you going to add 1 1/4? 4 times. 1 1/4 plus 1 1/4 plus 1 1/4 plus 1 1/4. So 1, 2, 3, 4. 1 plus 1 plus 1 plus 1 is 4. Numerator 1, 2, 3, 4. 4. Denominator, you don't add those. That's where the 4/4 came from. 4/4 is equal to 1. So 4 plus 1 equals 5. So if the number here equals the number in the house, then you did it right. So let's go through B. Y'all give me some blank stares. You're like, what are you got me into? I'm not going to say. I'm going to talk about what's over there. Okay. 3 divided by 2. 1, 2, 3. In half. How many halves do I have? 6. But also, what's 3 times 2? 6. So I didn't even have to really draw the picture, did I?
No,
I didn't. 6 halves divided by 2 is how many halves? 3. How would I write 3 divided by 2 as a fraction? 3 over 2. 3 halves. 3 over 2. So that's already written. But if it weren't, I would skip that step anyway for right now. Go over here. What goes on the outside? What goes in the yard? 2. It's 3 divided by 2. You're saying 2 divided by 3. How many times can 2 go into 3?
Once.
1 times 2. 3 minus 2. 1. So my answer is 1 and 1 half, which should match what's right there. So how am I going to check it? Yes, Emily Gilly. So you multiply the roof by what's in the yard. You should get what's in the house. 2 times 1 and 1 half. So how many times am I going to add 1 1/2? 2 times. 1 and 1 half plus 1 and 1 half. So what is 1 plus 1? 2. What is the numerator? 1 plus 1. 2. So now I've got my 2 halves. What is that? 1. So I've got 2 plus 1 is equal to 3. So this equaled that. So you're done. You got it right. Yes, sir.
Did you, like, on the homework, did you have to do a check?
Did it tell you to?
Of course you don't do that.
It tells you to, then you have to. On the homework, it's going to tell you to also. So right here on C, it didn't give you the division problem. It does give you the 24 divided by 4 equals 6/4. High five. High five. Good job. 6 divided by 4. They did give you the numbers over here. You kind of sort of had to figure it out a little bit, but not really. So do you think that you can figure out some more over here? See, y'all were giving me some blank stares up here, but didn't I tell you that by the time you got down to C, you'd be able to figure it out? Uh-huh. Okay, so go ahead and work a little bit on C. I'm going to pause this for a sec. Okay, so the number here in the improper fraction should be 6/4. So I'm going to come over here. I'm going to skip the mixed number part because I want to find the mixed fraction before I actually write the mixed fraction. I can't write it if I haven't figured it out yet. So I need to use the standard algorithm to find the mixed number. So 4 goes into 6 one time. 1 times 4 is 4. 6 minus 4 is 2. You get 1 and 2/4. Now I know that you guys asked me, should I simplify it? I know that I told you no. I'm going to, off to the side, I'm going to simplify it just to see if it makes a difference. I'm going to leave that. You don't. You leave it unsimplified. I'm going to do it to the side just to see if it makes a difference because I'm curious. Okay, so we know that it's 1 and 2/4. So to check it, number on the roof times number in the yard. 1 and 2/4 times 4. So that's 1 and 2/4 plus 1 and 2/4 plus 1 and 2/4 plus 1 and 2/4. Bless you. So we got 1, 2, 3, 4. 2, 4, 6, 8. So right here, I have a mixed fraction. Not mixed. Oh my gosh, I can't believe I said improper. It's been a long day. I have an improper fraction. Can I leave it? No. So I need to take care of this. I can't leave that. 8 divided by 4.
8 divided by
2. Is 2. So this needs to become 2. So 4 plus 2 is equal to 6. So this number should equal what's in the house, and it did. So I'm curious about this one. So 1, 2, 3, 4. 1, 2, 3, 4. And it's still improper. So that would be 4 plus 2, and you get 6 also.
Okay.
So it would have worked either way. If you had simplified it, it still would have worked. Okay. All right. Now on letter D. I'm not sure if any of you went ahead and worked it or not. So we have 5 divided by 2. What's going to go in the first part of my unit forms section? I know Emily knows. My goodness. All right. What about Cheyenne?
10 halves divided by 2 is 5.
So 10 halves. And that was really easy to figure out because I could take my 5 and my 2, multiply it, and it's being divided by 2, so I know it's going to be in halves. So 10 halves divided by 2 equals 5 halves. And then really what I'm showing here is that 5 halves. So what I get here is what it should be here. So when I have 5 halves here, I should have 5 halves here. So what I have here is what it should be here. And it's telling me that I should get 2 and 1/2 when I'm done dividing. So 2 into 5. How many times can 2 go into 5? 2. 2 times 2.
4.
5 minus 4?
1.
1. So my answer is 2 and 1/2. So when I go to check that, 2 and 1/2
Times 2.
times 2. So it's 2 and 1/2 plus 2 and 1/2. 2 plus 2. And 1 plus 1. So I have 2 halves equals,
1. 5.
so it's 4 plus 1 is 5. Okay. So, was this hard? Did I lie? No. Okay. Turn. Okay. So, on.
It's so bad.
Okay. Yes. Oh no. So, a principal evenly distributes 6 reams of copy paper. Now, a ream of copy paper is a pack of copy paper. Just a pack of copy paper. So, say Miss Chapman has to give the 8 fifth grade teachers, there's 8 of us, she only has 6 packs of copy paper, and she has to give all 8 of us paper. So she only has 6 packs. How much copy paper, how many reams would each teacher receive? How much would we get? How would you figure that out? What would you do? What would you write? Ethan. 6 reams of paper divided by 8 teachers. Write that as a fraction.
How is this 6 divided by 8? I thought the
6 reams of paper being divided among 8 teachers. So how much paper, what else, how much paper would we get? That's not improper. It is not improper. We would get 3/4 of a pack of paper. It's not improper. Guys, all I did was simplify it. You guys are so used to the other ones being improper that when I gave you one that wasn't improper, you freaked out on me. There were more teachers than paper. So, ha ha ha. So, now if there were more packs of paper than teachers, then every teacher would get a whole pack of paper. Right? And there would be some left over. However, if she only had 6 packs of paper, so we're going to pretend that right here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, right here in the front. And I only have 6 packs of paper. 1, 2, 3, 4, 5, 6. Can we do a 1 and improper mixed fraction kind of thing? No. So then we couldn't do 8 on top because it wasn't that there was more than enough. There wasn't. It couldn't be improper where everyone got one and. Was there enough for everyone to get a ream of paper?
No.
No, there were more teachers than paper.
Because he only had 6.
She only had 6 reams of paper. There were 8 teachers.
I thought you were supposed to divide things.
Now, what some people were talking about earlier was that actually taking 8 and dividing it into 6. Now, if you did that, you would not get a fraction.
It's impossible.
It's not impossible.
Like, get a below 0. It will be.
You would get a below 0 number, and what happens when you get a below 0 number? It's not a
It's
negative. That's when you subtract.
Oh. Positive.
Well,
Positive is a number.
She's still recording.
A decimal.
It would be a decimal. Now, what's really neat about this, that this actually became a teachable moment before, because of the fact that this is something that you actually need to know. So,
We starting with decimals again.
so 8 cannot go into 6. However, can 8 go into 16? 7 times.
Is we going into decimals?
Are
again?
we?
Are we going into decimals again?
So, now, with 3/4 and 75 hundredths, this is the thing about these two things. 3/4, 75 hundredths. They are equivalent. 3/4, 75 hundredths. You don't have to write this, I was just showing. 75 hundredths, 75 over 100, 3/4. You ever heard of 3/4?
Yeah.
It's like 75 cents. 3/4. It's all equivalent. It's all equal to the same thing.
I'm hungry.
75 out of 100, 75 hundredths, they are equivalent. This is not incorrect. It's just a different way to show the same thing. Decimals are related to fractions. They are related. They are related. So, this, in a roundabout way, they are cousins. So, this would not have been wrong, because a couple of the others were tempted to do this, and they were like, wait a minute, they weren't going to get a mixed fraction, they were going to get a decimal. And I said, well, technically you wouldn't have been wrong, even though we're kind of doing fractions right now, not decimals. So, if there were twice as many reams of paper, how many reams would that be then? 12. And half as many teachers? 4. How would the amount each teacher receives change?
3.
Each teacher would get 3. Then there would have been enough.
No, I said.
Okay, thanks. 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 Okay. Now, number 3. There were some people who got very confused on number 3. And there's nothing wrong with getting confused on number 3, because this is you really have to extend your thinking on questions like number 3. Some people were like, oh yeah, boom, got it very easily, and some people I had to really draw it out. So there's nothing wrong if number 3, you kind of go, huh? It's fine. So I really want you to look at number 3 and okay. So it says a caterer has prepared 16 trays of hot food for an event. The trays are placed in warming boxes for delivery. Each box can hold 5 trays of food. So this is your important information. He's prepared 16 trays. Each box can hold 5 trays. How many warming boxes are necessary for delivery if the caterer wants to use as few boxes as possible?
I'm scared. I know
Okay.
it's true.
So try to answer that question.
Oh. That is easy. What? First of all, the inside has a room. Do we do them 0 things or just leave it?
You haven't even written anything. Need to write something.
I'm gonna. Sons.
Stop. Trying to pull up the other thing. There you go. So, how many of you think it's 3 boxes?
Wait.
How many of you think it's 3 boxes? How many of you think it's 2 boxes? How many of you think it's 4 boxes?
Wow.
How many of you think it's 5 boxes?
Nope.
How many of you haven't even worked it? Okay, so there are 16 trays of hot food. There are, and there are 5 boxes that can hold those 16 trays. So it's 16 divided by 5. So 5 going into 16. How many times can 5 go into 16?
3 times.
3. With a remainder of 1.
Yes.
Okay, so essentially,
There's 0 times. No, there's circle. There's circles. Circle.
so each box would hold 5. Do you agree?
Yes.
And there's that 1 tray left over. Is he going to leave that one at the shop?
No.
Is he going to leave it on the ground?
No.
Is he going to drive with it in his lap or something?
You gotta smush it.
So apparently he would need 4 warming boxes. Why would he fix 16 if he's not going to keep it warm? He obviously needs it. So he would, they're just saying the fewest boxes possible, which means that he wouldn't take 5 or 6. He just can't take 3 because he has that 1 tray left over. He needs 16 trays of food
So it's barely full.
because he must be feeding that many people. He needs 16 trays of food. But 3 warming boxes isn't enough to carry all the food. He needs 4 because he has 1 tray left. He can't drive with it in the front seat. The food will get cold.
Apparently, what if there's 16 people?
No, there is no what if. There is no what if. He needs 4 warming boxes to carry the tray. There is no what if. What if? No. There is no. If the caterer fills a box completely before filling the next box, what fraction of the last box this one? What fraction of the last box will be empty? What fraction of the last box will be empty?
1/5.
4/5. It's only got 1/5 in it. It holds 5. It has 1 in it. So it has 1/5, and 1, 2, 3, 4 aren't in it. 4/5 is empty.
We eat that.
Come on.